Kinetics flashcards for chemistry. Define reaction rate. Reaction rate is a change in concentration of reactant or product over time. Yeah, it's really important you say or product because it's not always necessarily going to be a reactant. So change in concentration of a reactant or product over time. Formula for a reaction: amount of reactants used as product form divided by time. State two keys. So reaction rate, the change in concentration of reactants as a product over time. State two key conditions for particles to react. For particles to react, two key conditions: they need to collide in the right direction, and they also need to collide with a minimum amount of energy, kinetic energy, and that's called the activation energy. Collide in the right direction, need to collide with a minimum amount of energy. Draw entropy profile diagram for activation energy. So here you go. Bond entropy, progress of reaction. Here is the reactants, and this is where the bonds are being stretched. Then you go here, this is the activation energy. The bonds break if the particles have enough energy. And then you go here, that's your products, and this is the energy barrier particles have to overcome. Define Maxwell-Boltzmann distribution. I think this is really nice because it helps you with your understanding of what it actually is. It's a graph of the number of molecules in a gas with different kinetic energy, and it shows you, a graph of the number of molecules in a gas with different kinetic energy. What happens is shape of Maxwell-Boltzmann curve as you increase temperature, it pushes it over to the right. These come up as one marker. It will give you the Maxwell-Boltzmann curve that said student increase temperature, draw the new graph. You just need to know it pushes it over to the right and practice it a couple of times. Why does increased temperature increase with reaction? More kinetic energy, collide more often, greater proportion of molecules have energy greater than or equal to activation energy, therefore able to react. Why does increase in concentration increase with reaction? Well, increase in concentration, particles are closer together, collide more frequently, therefore more often, therefore more chances to react. What is increasing pressure due to reaction? Increasing pressure, well, all gas particles are close together, more likely to collide, more often, more frequent collisions. Draw energy profile for Maxwell-Boltzmann distribution. Here you go, energy. That's your reaction pathway, that's your reactants. This is the delta E without catalyst. This is your delta E with a catalyst. And that's your products, and that's delta H, and that's your reaction pathway. Define dynamic equilibrium. State key fact about dynamic equilibrium. Dynamic equilibrium is the idea that at equilibrium, the concentration of reactants and products stay constant. So dynamic equilibrium, at equilibrium, the concentration of reactants and products are not the same. Please understand this. They're not the same. Dynamic equilibrium, at equilibrium, the concentration of reactants and products stay constant. Because I've seen a multiple choice question on this, and it was about dynamic equilibrium, and option was they're the same. They're not the same. They stay constant. State key fact about dynamic equilibrium. Dynamic equilibrium can only happen in a closed system. State Le Chatelier's principle. So a lot of definitions for this topic. The idea that if a reaction at equilibrium is subjected to a change in concentration, pressure, or temperature, the position of equilibrium will move to counteract the change. If a reaction at equilibrium is subjected to a change in concentration, pressure, or temperature, the position of equilibrium will move to counteract the change. Define homogeneous equilibrium. A reaction where every species is in the same physical state, all liquid or all gas. Okay. What happens if you increase concentration of reactant? What happens if you increase concentration of product? If you increase concentration of reactant, equilibrium tries to move extra reactant, making the product shift to the right. If you increase concentration of product, equilibrium tries to move extra product, reverse reaction goes faster, equilibrium shifts to the left. That makes a lot of sense. What do ionic half equations show? Ionic half equations show the oxidation or the reduction. Define oxidation, define reduction. Oxidation, a loss of electrons is oxidation. Remember, oil rig, oxidation is loss of electrons, reduction is gain of electrons. Define redox reaction. A redox reaction is when reduction and oxidation happen simultaneously. Oxidation is loss of electrons, reduction is gain of electrons. Define oxidizing agent. Oxidizing agent accepts electrons and gets reduced. So it's electron acceptor. Define reducing agent. Donates electrons and gets oxidized. It's an electron donor.